All right, let's enjoy logarithms. Example 4c. Here again we have an equation with the variable x. Once again, we're fortunate that the variable x is in only one term. That allows us to use inverse operations to isolate the x. And if x was in more than one place, it makes it much more difficult, and it would not be that conducive to college algebra. And we'd use techniques we learned in future math classes, like calculus. We'll see y'all in calculus in the fall. Okay, so anyway, but you can use simple algebra on this one. And again, the question is, in the order of operations, what operation is furthest from x? So, parentheses, exponents, multiply, divide, add, subtract. I hope you would agree with me that that add 17 is the furthest thing down the list. It's the furthest operation from x. That's the language I've used for a while. What's the furthest operation from x? In the order of operations, and it seems to have clicked with people. So when things click with people, I keep using it. All right, so you get rid of that add. Let's subtract. Inverse operations. I hope you agree that that multiply by 2 sitting out there would be now the furthest operation down the list from x. How do you get rid of multiply by 2? Divide by 2, exactly. All right. And so at this point, I'm trying to plan ahead for board space here. I think I'm going to move this up here, all right? So doesn't that leave us with 5 to the 8x minus 7 power equals 459. That would be 918 divided by 2. I'm nervous as heck. I'm going to make a silly arithmetic mistake. And if I do, I apologize, but hopefully, again, the process makes sense. So 918 divided by 2, I'm nervous, I'm checking. That's 459. All right, now, what do you think looks to be the furthest from x? The 5. Yes, I agree. And the question becomes, so what role is 5? For example, back here, 2 was a multiplier. That's why we divide it. The recognition that would need to take place here would be the fact that that 5 right now is a base. It's something that has a power attached to it. So I'd like to emphasize that that 5 is a base. And by doing so, I'm hopefully triggering in your mind that the equation on the board right now is a base raised to an exponent equals something. A base raised to an exponent equals something. And when you want to get rid of that base, when you want to get rid of that exponential relationship that's on the board right now, you change it over to log. So that would be, we currently have an exponential equation and we change it over to log because that's the inverse of an exponential. So this would be the log base 5 of 459 equals 8x minus 7. That was the pattern that we practiced multiple times on examples number 1 and 2. And that's why we practiced it so much on examples 1 and 2. So I, again, would highly encourage you to watch these in order because, again, they build on each other. Changing this to this was practiced multiple times on examples with number 1 and 2. Now, log base 5. Log base 5 doesn't get its own calculator button. All right, there are some calculators that allow you to put whatever base you want, but the majority do not. This would hopefully be the point where you'd realize that in order to calculate that logarithm, we would need to employ change of base. All right, so that again was introduced on a previous example. So on paper, you hopefully remember, I'm changing this, I'm doing change of base here to this left side of the equation. Base in the basement, anti-log in the attic, and then you pick whichever logarithm you want to do. I usually choose natural log, so let's do natural log to both of them. I could have done common log to both of them. It doesn't matter. They both work. As we saw in a previous example, it doesn't matter which one you change it to. Just make sure you change it to one that the calculator can do. All right, so then calculator, which very hard for you to see this. I don't know. Maybe, I don't know. I'll try this. I'm going to put in that. Okay, so I'm hitting ln Still can't see it. I know. ln 459 equals. Still can't see it. I don't know. I'm trying. Natural log of 459 equals. Then I hit divided by, and then natural log of 5. Boy, this is really high tech, isn't it? But anyway, if you put this in a calculator, it should give you something like 3.808193011. Did I write that right? I think so. Again, if I make a silly mistake, laugh at me. The major point is you understand the process. All right? And again, you're like, well, you don't give us a break when we do the process right, but we make silly mistakes. Touche. But anyway, then we'll add the 7 and so forth. So now we have 10.808, blah, blah, blah. Keep all the digits that you can. And if your calculator keeps fewer digits than mine, no big deal. And then, of course, the last step would be to divide by 8. So bringing this over here, it looks to me like the final answer would be, add that over, divide out the 8, and we're looking at 1.3510. Again, I hope the process made sense, and if I make any silly mistakes, you're not here to point them out to me. So I hope all my arithmetic was correct. But there you go. So once again, we're using inverse operations to isolate that x. And I would say the one step in this that was new to us was getting rid of that base by changing it to a logarithm. Because again, exponential and logarithmic are inverses of each other. All right, rock on.